Hi, good morning. It's Jim from the Mavestar Observatory. Okay, I'll explain why I'm doing a video at 5 o'clock in the morning. That's because sometimes I do suffer occasionally with insomnia. I just wake up and, I just know I'm not going to go to sleep, so there's no point even trying, because have you ever had it? You can lie there for hours, can't you, and just not go to sleep. So I thought it'd be a good time to catch up on some emails. And we've had a few interesting ones again from Harvey. Thanks for that. And in one of these emails, he sent me this to do with heliospheric modulation. And I won't bore you with it. I'll just get to the interesting points, because it's important for us to look at these things, because it gives us an idea of how healthy our sun inflates the heliosphere, which is like that invisible bubble that protects our solar system from the inbound or incoming cosmic rays. And in particular, this chart is looking at the neutron rate over the solar cycles, and I'll show you something interesting I found about this. First of all, you can see that around 2008, at solar minimum, there's a higher frequency of neutrons, and the reason for that is because the heliosphere has shrunk a little bit and more is coming in as a result of that. And if you look to around about 2015 on this graph, you can just see that that is the lowest point, or the lowest frequency. The difference between that solar minimum, solar maximum is about 22 Hertz. So during solar maximum, the heliosphere has increased in size and therefore pushes away more cosmic radiation to the tune of around about 22 Hertz, as opposed to when it's at solar minimum. But what I was interested in is the fact that it didn't drop into its trough until after 2015, and yet solar maximum was 2014. So there's obviously a lag time of about 15 months in that. And I think with that lag time and the difference in Hertz, we can probably work out that if we start to see, the graphs changing and the Hertz rates changing, we can work out how far our heliosphere is actually at, because of the time delay it takes for these neutrons to come into our Earth's atmosphere and be detected. So for that reason, I thought it was important just bring it your attention that there are methods we can use to measure the actual inflation of the heliosphere by studying over a long period of time, from 2008, as you see here, to 2017, a whole solar cycle of activity with regards to incoming neutrons. So just bear in mind 2014 on this chart is really where solar maximum occurs, and I'll just prove that for you. So if ever you're curious as to how the solar cycle is getting on and you just want to focus on this particular solar cycle, well, you can always go over to poleshiftnews.com, and if you go under I think it is let's have a look for you, live solar data, in the more section on the right hand side of the screen, you'll come up with all this data. If you just scroll down, you can get to this chart, which as you can see was last updated on the December the 9th 2019, so a few weeks ago it was last updated. But you can see sunspots are at the lowest, but the more important point is here we can see that around 2014 it was at solar maximum, and we see on the other scale what we was looking at, there was more Hertz coming through at around 2015, around 15 months after that. So if we look around about on the solar cycle where that was, it was around here where the cursor is. I just hope that the cursor's not out of sync with what I'm talking about, but where you can see the cursor going up and down is the lag time that these neutrons took to arrive at the detector. And I think with some calculations you can work out how far the heliosphere is from that. Or if we're just looking at that scale again, I'll just bring it back up again for us. So to work out how far the heliosphere is away from the sun, and if it is deflating, then what we'd be interested in is looking first of all at when solar maximum was, during the cycle, and then also the frequency of hertz it's at. And then if there's an increase in frequency at solar maximum, and there's a shorter delay lag, we know that the heliosphere is reducing in strength, and as a result of that we should get an increase in neutrons. And these charts here can show that without us being directly told by these organisations that that is what they are probably interested in, and that's why they're monitoring them. There's a lot of work going on right now with cosmic radiation all around the world, and all these big institutes are getting involved in the study of cosmic radiation. And you've got to ask yourself the question, guys, is why would they invest literally trillions of dollars into research facilities just to study that one thing, cosmic radiation? It must be of importance to all these institutes, and it would warrant obviously there's a reason why the funding is provided. So what I'm saying is that there must be a justification for it. But the good thing is, if we can get data like this, we can work out, just by keeping the data now and then comparing it with the next solar cycle, we can work out the condition of our heliosphere. And that's all we really need to know. If we can work out how the heliosphere is shrinking, we can also have an indication of as to how much cosmic radiation is inbound, and then we can assess the levels of threat to biodiversity on the planet as a result. So it was great that Harvey sent that, because otherwise we would still be none the wiser with regards to heliospheric strength and heliospheric modulation. And that is exactly what we're looking at over the course of one solar cycle. We're looking at the modulation of the heliosphere as well. So by the study of neutrons, we can work out where the heliosphere is, if it's shrinking, and over what time period. And a chart like this can always be used at a later date to go back on when we get more data in the future. And like I say, I think it's important. So just briefly moving on to an interesting conversation I had today with a friend in the United States. He was telling me he was just overwhelmed with all the possible events that could take place, and we went through a few of these, and I just tried to clarify for him just a few things that we know is going to come, and perhaps preparing for them is the best. Just some of the scenarios that came up in that conversation was a micronova, and I said it's not really worth investing too much time into worrying about such an event like that, because there's nothing we can do about it. From the time it happens, it's only going to be 8 minutes until it arrives here on the surface of the Earth and takes its effects, and that's going to probably be a grid down scenario. It's going to fry up all the substations locally to ourselves, and the electric's going to go off as a result of that. And then following that, no fuel will be pumped, and the logistics will collapse that supply the cities, and cities will decay within about 2 weeks, and public behaviour will deteriorate in 2 weeks' time. But there are a lot of other scenarios that can lead to similar effects. Like another topic that came up was the economic collapse looming. We have internationally overprinted money, and as a result of that we've devalued it. It's the same as any other commodity. When you have more abundance of something, it becomes less valuable. And it's another interesting conversation, just diverting away from that. I was at my parents' house the other day, and we was looking at the new £20 note that's just been launched for this year, and it's plastic. And I said, that shows its true value, doesn't it? And it's like everything else, when by the time it gets to be made out of plastic, then the price drops dramatically of it, or the worth of that object that's made out of plastic, because it's probably such an abundant material. I mean, just look at the carrier bags and bottles, on a rubbish tip. Just gives you the value of it, doesn't it? 1 ton of plastic is not worth 1 ton of copper. And we just have seen over the recent years here in the UK, the currency which used to be made out of copper now is an alloy of copper, and that's simply because the cost involved in the material making it isn't worth the actual value of it when it goes into currency. And a good example of this was, if you go back 1,000 years, we was using gold shekels and silver shekels. That was the value of currency then. And then over the time, we moved from valuable metals to paper currency, and now the currency's turned to plastic. It just gives you an idea, doesn't it? But yeah, going back to that subject, our economy is in a poor state, and it's terrible when you look at the world today. We thought by incorporating technology things were going to get better, and they should have, and they could have, but there is something that is completely wrong about our system, and that is the competitiveness. And when you incorporate competitiveness, you will incorporate the need for people to be corruptive. And when there's a need for money and there's an element of corruption involved, allowing somebody to get their hands on that money, then generally human beings do take that shortcut. And in the end of the day, that is why we built technology in the first place, to make things easier for ourselves. But if you can cheat to get your hands on these things that you need, then it seems very logical at the time to do it. But it's not. What's the word I'm looking for? It's not the conscious decision that we should be making. So the economy is in the state of it is because of the competitiveness and the corruption. And what we're seeing is people put their conscience away in a closet in order to make more money, and as a result, people are losing their jobs. I knew it was going to come to this when I saw the first till at the checkout in the supermarket being fully mechanised. The one that you scan yourself, you put all your packaging in your bags yourself, and then you just press you want to pay with your card, and then you're out the shop and you haven't even seen a cashier. Well, I knew cashiers were going to go when I saw that, and it was just another line of workforce deteriorating before our eyes. And we've seen technology do this in a multitude of working sectors. I had the conversation with another friend that I could fully mechanise McDonald's. You wouldn't need a single person there. We could have a robot that would measure the cooking temperature of a burger and cook it perfectly, and it would be a better product made by robots than it would human beings. And robots now make coffees. We could just mechanise absolutely everything. Whatever you can think of, it could be mechanised. We don't really need pilots in planes anymore. They generally fly by GPS in any case. The majority of the time, the pilot's just there to oversee all the instruments. But why have a pilot when we can have computers check all those instruments? And if there is a problem, then the aircraft can take a decision on that, whether it's a serious threat or not so serious. It can continue in its journey, or if it needs to land at the nearest airport, it can select that airport, communicate with another computer on the ground, and the airspace can be cleared and that plane could land. We can mechanise absolutely everything. We don't need train drivers, we don't need lorry drivers, we don't need ourselves to drive cars with the technology we've got. But the problem is, if we mechanise everything, then how does the monetary system tick on from that point? And in any case, how long is the monetary system going to be if it doesn't collapse itself? How long is the monetary system going to be in place if some of these scenarios that we're looking at do take the route that we think they're going to? If there is a solar flare or a micronovae, what good is money going to be to anybody at that point? I was talking to this friend in America today, and I says at the end of the day, it's not new what is going to happen. And the thing is, we've got the data in front of us. This chart shows us what's coming next. It's like a crystal ball for the future. We are definitely moving into a glacial period, and there are a few other circumstances with regards to a couple of other anomalies that are taking place that are going to possibly bring that in quicker. And that is the grand solar minimum and the reduction of our heliosphere. As we started off looking at the data with regards to that, we can see is taking place, and we're also in the midst of a magnetic reversal. Yet to be a full magnetic reversal, could easily be an excursion, but nevertheless, if it is another excursion, the same problems occur. We have more cosmic radiation inbound, and that in turn affects the climate, and in turn affects the growing abilities of farmers to mass produce food in order to keep 7 billion people fed. We are really clutching at straws with a lot of things at hand right now, and they are going to continue, as we can see, to get worse. We know they are. So my advice to my friend was, if he had the affordability to do it, would be to go and buy a little piece of land out off a driveway that's a little bit too much of a convenient for somebody to travel down there, and put yourself out there and with your loved ones, try and make it interesting, a place where you can leave the city life, and even if you just toe dipping, going there on the weekends, just make it enjoyable, somewhere where you can relax, get stuck into growing a bit of food for yourself and have a different lifestyle. And then if worse comes to worse and things do fall around your sides, you can always shut the door on your city home and bail out to that quiet place. But for the majority of us, I know it's not easily accessible, simply because we don't have the funds to buy that little bit of land and build a small cabin on there. So for the likes of us, we're going to end up in the same situation as a lot of our ancestors have when this has occurred to them, and the cities have failed. We're going to have to put whatever we can on our backs and migrate to a place that is more sustainable for us. It's going to be difficult times for a lot of people, because a lot of us don't know even how to light a fire with a fire striker, or another piece of wood. We don't know how to make a fire bow, and a lot of us don't know how to source food for ourselves, and these are the skills that haven't been taught in the schools, which I find horrendous, because we have been so complacent, relying on state to do so much for us. If we just at the dial of a phone can have a medical assistance, then how does that work in a grid down situation? And after everything has fell away, all our technology has gone, and how does that work then? The old methods there was the witch doctor in the village that probably knew some basic remedies that he could make with what he had in the surroundings, and help that person with their ailments. And that's probably the way we're going to go back. And that's why I said to this friend in the States, probably one of the good things would be to have at hand would be a aromatherapy book, something that shows you how to make medicines with the natural surroundings. And a survivalist book, a book like a bushcraft book would be a handy book to have, so you could see how to light a fire, and you could forage some simple foods for yourselves and your loved ones, if that came to be. These things don't cost a lot if you just put up a few things in a bag. I've always said that it's the best insurance policy for you and your loved ones, and you want to hope that you never need to use it in your lifetime. But we should always talk about to our children and their children about times that in the future could change, where they will possibly need to use them. And how far a future are we talking? Well, I've said before, all these events now are at front door, and they could easily swing into action in a matter of months. Looking at the magnetic pole migration, we can see it's probably 4 to 7 years away, and not just at the rate the pole's moving, but at the decay of Canada. High intensity over there, the magnetic intensity is shrinking away very rapid. and we're going to start to see more of what we have done, sadly, over the last 30 years with, climatic disorders, severe changes in, seasons. What we was used to relying on, good weather in the summer and poor weather in the winter, is changing, and it's going to affect, first of all, crop production, as it is already, and then when you throw in other things as well, due to climatic change, with viruses and problems that can occur in not just ourselves but other biodiversities, like what we're seeing now with the rise in China of swine fever, moving from South Africa first of all, then to China, and then it's going to find its way into Europe and then over other territories. These are the things that we're going to have to deal with, short term, long term. We really need to make some plans and we need to be ahead of the game. And getting back to what we've done this year at the observatory, we've put some magnetometers out globally. A few magnetometers that we got out there are going to be replaced shortly, because we've not had data come from a couple of those, so we're going to ask a few people over in the States if they want to take over running those magnetometers for us, because what the idea of these is to get regular data, and some people have the time to do it more than others, and we get some great data from Australia, we get some great data from Hong Kong, and really we need the data not just from the United States to come in regularly, but we also need data next year from our muon detectors, and we need reliable people that can feed it back to the observatory where it can be converted and put up onto the internet. So we took it upon ourselves to build a magnetosphere sensor this year and put 5 magnetometers out into the field globally, and next year we'll be pushing again to expand the observatory with muon detectors, so that we can keep an eye on the increase in cosmic radiation in our upper atmosphere, and maybe other things like CO2 monitoring, as we're now doing, and oxygen monitoring. Maybe we'll extend that into the field. And the whole reason of doing all this is so that the public are not shut out the loop with regards to the importance of the information that we have taken it upon ourselves here at the Mavestar Observatory to bring to people, because it seems that there is a lack of data coming in from these mainstream organisations, and there does appear to be a closed loop around that data. So if an observatory like ours can get that data to you and keep you informed of these events that are occurring, maybe we might benefit from an early warning of things rapidly changing, and at that point might just give a few more of you people out there time to get some stuff together. So we're on New Year's Eve, guys, and we're moving into 2020 in the next 40 odd or so, 36 odd hours. So the only thing I want to wish you right now is all the best for next year. If you followed us, then continue following us, and if you're a supporter, you want to support what we do down there, the link's there, you can do it, and we'll just keep on doing what we do here at the observatory in 2020, and that is expanding and bringing more data to your attention. And don't forget, guys, there's plenty of stuff on the website already. We cover sea ice extent, solar data, earthquakes, volcanoes. We've got live feeds for Schumann frequencies, radiation, with regards to cosmic rays. We've got our own data on the TriMag, which is the tracking of the magnetic North Pole, and the magnetosphere, and all the data that we collect globally as well. So there's quite a lot on there, guys. And we're just going to expand that next year and make it a one-stop shop for everybody. So with that, guys, if you want to support us, links down there in the description, and I'll say what I usually do. You take care, have a great new year, and I'll catch you in 2020. As always, bye for now.